There. All right. In theory, we're live. Hello, everybody, and welcome to the virtual star party for Saturday, the 28th of November. We're gonna have an action-packed evening tonight. We've got a lot of good stuff queued up, a lot of telescopes. It's gonna be a really good night. The downside is that the world will not let me go ahead with my plans to destroy the moon. And so the moon is almost full. It's going to be right there, smack dab in the middle of everything that we're trying to do tonight. So just be prepared for things to look a little worse. And that's the moon's fault. So unfortunately, that's what's going to happen. All right, I'm going to get out of the way. This is the last you're going to see me at this size. Joining me here from California, we've got Stuart Foreman. Hey, Stuart.
Hiya.
And it's cool. Great view. You can see your telescope there behind you.
Yeah, I positioned myself just so you can see that we're not making this up.
Yeah, that's a real telescope. Watch as it turns around in different locations. Right. Yeah. Also in California, we've got Molly Wakeling. Hey, Molly.
Hello.
How your skies?
My skies are looking really good. The moon is still a little bit behind my neighbor's garage, but we'll be able to take a close-up peek at that here in the next 20 minutes or so. Meanwhile, we can go look at Mars.
Right on. We got Linda Thomas Fowler. Hey, Linda.
Hey.
And you finished your move.
I'm coming to you from the Shenandoah Valley instead of just west of Dulles Airport, but the telescope's out in West Virginia where the moon is casting nice harsh shadows on the observatory.
Yeah, so like people want to see the effect of the moon. This is nighttime, and we are looking at Linda's observatory, and you can see what's going on here. We
do have Orion peeking up over here.
Oh, that's great. Yeah, well, you're 3 hours into the rest of our future. Yeah. And then joining us again, we got Roy Salisbury. Hey, Roy.
Hey.
And you're in Arizona right now.
Correct.
And
I'm out at my observatory in Arizona.
Excellent. And you're on a cell phone connection, so if we don't hear much, I will blame it on your cell phone connection until we get to that Starlink anyway.
Yep.
All right. Well, Stuart has already come out of the gate with something. So, Stuart, why don't you tell us what we're looking at?
This is the Dumbbell Nebula. It's one of my favorite objects because it's one of these ones that looks exactly how it's named. So It looks like a bubble. And this is just a 2-minute exposure of hydrogen alpha. And so there's obviously a lot of noise. But you can see the structures of this nebula with the hydrogen alpha surrounding it. And it's really nice and red, although I can't get red right now, so I'm just going to see hydrogen alpha, but it's still really nice definition with this.
Yeah, that's really cool. I love this bubble shape. Do we know? I should clearly learn. I don't know anything about the Dumbbell Nebula. I'm assuming it's like there's a star forming region.
It's a Wolf-Rayet star that's or something like that. It's just some star with a really strong stellar wind, I believe.
Yeah, okay. Yeah. So it's got a hot star that's blowing out this bubble. And it is like a bubble of gas surrounding, like it's like the stellar winds coming from the star are so strong that it's just blasting out this region. Yeah, it's really incredible.
Yeah, that's and this is NGC 7635, and it's about 10 light years across.
Really cool.
Mm-hmm.
Discovered by Herschel. Apparently, it says Wikipedia. That's awesome. Wonderful. Anyone else got anything?
I've got Mars.
Oh, hold on. I think Roy shared his Andromeda. So we'll do this one first, and then we'll shift over to your Mars once it's ready, Molly. Oh, there we go. Okay. Awesome. And color. That's what I like. That's what I like. Yeah, that's beautiful. And this is taken tonight, right?
Correct.
Yeah, and you can
It
really
is
see
a 2-minute exposure with a color camera.
And so I'll just sort of show people what we're dealing with this stupid moon tonight. So here's the sky in California anyway. So here's M31. So that's Andromeda there. And there is the moon over there. And so it's pretty close. I'd say it's within about 40 degrees. So, when you've got the moon, like a full, and it's pretty much a full moon. Hopefully we're going to be able to bring a picture of the moon. Like, fine, we'll take a look at it. It wants to be in the show, so we'll do it. But, normally when you get a full moon, if the moon is over here, you're looking over here. You're looking at stuff on the other side of the sky. So it's pretty amazing that we've got a view of Andromeda, which was pretty close. You can definitely see that the light pollution that's going on in the background there, but still.
Yeah, if you look in the corners, you can really see it.
Yeah, you probably had to stretch it quite a bit.
Yeah.
And I've got a 2-minute exposure of Andromeda that if you compare it to a couple of weeks ago, you'll see it's not quite as detailed, although it's not too bad.
Oh, great. Okay. Yeah, we'll sort of compare and contrast. And I like the how you can see like just the dust lanes and all of the, you can see some of the nebulosity and star forming regions up at the top there. That's great. It's such a tough object. It's like so bright in the middle, and yet the outer edges are.
Well, a lot of beginners try to image it, and they realize that they can only get a tiny little bit of it. Number one, because it's so huge.
Yeah.
It's several times as large as the moon, and the dynamic range of it is so high.
Yeah. And so it takes some special technique to actually be able to pull it off. So we'll go over to Linda's view. Oh, come on. I got too many pins. Did I remove that pin? There we go. Okay. All right. There we go. And then I broke it. Okay. All right. I'll fix everything in a second here.
So yeah, we've got 2 minutes of M31 here through a luminance filter.
Yeah, and same thing. You can definitely see. I can see you probably stretched it a bit. You can see the light pollution surrounding the shot, but
yeah, normally, in fact, you can see the histogram here, and normally this would be way over here, and that the moon glow is pushing the histogram way to the right.
Yeah. Cataclysm 1234 is asking, when the images come through, are they originally in black and white, or how do you develop the images?
So mine are in black and white and shot through colored filters, and I think everyone here tonight except for Roy is using a monochrome camera.
Right. And in my thing, I'm just doing a simple auto stretch to the image just so we can just quickly see it.
Yeah, if we look, this is what it looks like out of the camera here, and then this is the same kind of auto stretch that Stuart's talking about applied to the image. So it takes this and stretches it out just like that, so you can kind of get a sense for what it does to the data.
Yeah.
Right.
Yeah. All right, so let's go to Mars, because Molly's got Mars happening. All right, so how do I bring everybody back?
Yeah,
to the
so I've
middle?
got Mars here.
All right.
I'm using my black and white, my monochrome camera tonight, because every week that I do this, I have to swap cameras back and forth between my two rigs, and I just didn't want to do that tonight. So, but I can also show some views of my color camera on my wide field rig.
Well, last week or 2 weeks ago, you shot, and I still think probably the best Mars that we've ever seen in the Star Party, and you were shooting a bunch of video. Did you ever get a chance to process it?
So I tried to process it. I was having some trouble with it, and I haven't gone back to further address the issues.
Okay.
So,
That would be no.
Yeah, I haven't. But I've had some other projects I've been working on. Mainly, well, the sun took up all my time this week because we've had some excellent sunspots this week. So that's been taking up all my spare time that I have for processing.
Do you have any shots of that sunspot?
I do.
Yeah. Maybe
I
you've
Heard of sunspots.
I'll go back to. I'll go to Stuart's
ages.
shot, and then
Yeah.
if you can share them.
Pull it up.
Yeah.
So, are we on me?
Yep, we're on you.
Okay, so I have this is the middle of the Heart Nebula. It's called Melotte 15, and for people with wide field cameras, you can see the entire nebula looks like a heart. For me, I can just see the middle of it because I have a much narrower field of view. But you can see kind of the part of the heart there, and this is the center of the heart right there. And this particular structure is called Melotte 15.
That's really cool. I mean, we talked about this before that you're getting structures in it. You're getting pillars that are similar to like the pillars of creation in the Eagle Nebula. You're not quite as pronounced, but you can definitely see these darker regions. And I'm assuming there are stars located, newly forming stars located inside some of these. Very cool. Right on. Oh, Molly, that's incredible.
Thank you.
Yeah. Look at that.
This is so they've moved more toward the center of the sun, although I haven't had time to process the ones I took yesterday where it's more toward the center of the sun. So this is from Tuesday or Wednesday, I think, where it's more toward the limb. But this is with a white light filter, so not a solar telescope. This is on my 8-inch. I have a little homemade filter cell that I put a Seymour solar filter paper inside of, and in a nice little off-axis solar filter. And I was pleased to be able to get some of the detail in the outer ring of the sunspot, as well as a lot of plage activity there. Plages are the lighter colored regions there. So this image I colorized to make it look like the sun. I took it with my black and white camera, but this is the color that I see through that filter when I look through it visually.
Now, did you catch the story about this sunspot group that astronomers actually predicted that it was going to appear before it did?
So I saw that they knew that it was there, that they knew that it was present, but we hadn't rotated around to our field of view yet because of some really cool acoustical stuff or something like that.
Very cool, very nice picture.
Yeah.
But we've shifted now to Roy's shot again. Roy, what have you got here?
Well, since Stuart had the bubble up there, and I just figured I'd do it in color.
Nice.
Can you zoom in? But you've got the cluster up in the upper left there. So this is, I mean, that's a pretty wide field camera that you've got on this telescope.
Yeah, it's a pretty wide field. Yeah, this is my refractor. Gives me a really good field of view on this for larger nebula and objects.
Yeah, that's really great. Yeah, so there's the Bubble Nebula has this open cluster in the upper left-hand corner that kind of goes along with it. And so a lot of times people try to get both in the shot.
Well, I had both in the shot. You wouldn't let me show it because you wanted me to zoom
No,
in.
I know.
This one. There's this over here.
I have different rules for different people. Sorry, Stuart. What have you got, Stuart? I see.
This is the Fishhead Nebula, which is it's not a real nebula. Everybody calls it that. It's just part of the Heart Nebula, and you can kind of see the fishhead nose and the fin going up and the tail over here.
Wow, I've never seen this before.
Yeah, it's just at the top of the Heart Nebula. And it's a real cool structure. I haven't formally imaged it yet, but a guy in my club did. And I said exactly what you said. I said, Oh, that's cool. I haven't heard of that.
Yeah.
Yeah, that's a really cool part of the heart.
Heart and soul.
Yeah, I got the
The
soul
Heart and
also.
Soul Nebula.
I got the soul. That's later
Okay.
on my list. I have that up.
So I have one for you when you're ready, Fraser.
Yeah.
This is something off the beaten path. It's called LBN 581.
What?
And it's
I want to see.
it's really strong in hydrogen. This is
neat.
actually. I'm sorry, Story?
I just said, oh, neat. I've never seen that.
Yeah.
Oh, it's really strong in hydrogen. The sulfur and oxygen are pretty thin. I still need to collect pretty much any data there. But this is 1 10-minute hydrogen exposure. And there's just lots and lots of cool detail in there. If we zoom in here, we can
Oh, wow.
see some of that.
Nick W. is asking, any recommendations to someone wanting to get into astrophotography in the cloudy and light polluted European Northwest?
So I'd recommend using a fast telescope, so something with a fast focal ratio like f5, f4, or camera lens, so that you can get more light collected in a shorter period of time to get an image processed. If you own a Canon DSLR, you can get a Sony DSLR, you can get a clip-in filter of a light pollution filter. I use the Astronomic CLS CCD, and I like it quite a lot. So that's a good way to deal with light pollution. And then if you have a fast camera lens or a fast, let's say a refractor, then you can collect a lot of light in a short period of time on those nights that you do have clear.
There's a great book recommendation by Charles Bracken called The Deep Sky Imaging Primer.
Yeah.
And the second edition is out for a couple of years now, and it does a wonderful job of taking you from nothing through processing. And it's a very accessible book.
Yeah, I mean, I think I've seen pictures of Europe, like you look at like the dark sky finder, and there's no dark sky to be found if you're in like the Netherlands or just the north. That whole area, the Benelux area, is rough. You can go out into the ocean or to the Alps or something, but it's pretty hard. But I mean, with some of these narrowband filters, like what Linda is using, you can be shooting in the middle of a city with narrowband filters, no problem. So
Yeah, I've seen images from someone who shoots in basically the Light Dome of New York City and does incredible work. But it's all narrowband.
Right. And so that's the key, is that it's narrowband.
Yeah, I've been moving more in that direction as well since I live in the Light Dome of San Francisco.
Yeah. But the narrowbands are not cheap. Like,
Oh.
Well, the entire hobby's not cheap.
the entire hobby is not cheap. Yeah.
If you want to go cheap, pick another hobby.
Yeah. I think Linda,
like cross country running.
yeah. I mean, I think Linda was suggesting towards the inexpensive side with a light pollution filter on your DSLR, for sure. But if you want to go get serious, then you go narrowband filters on a proper astrophotography rig.
But even
something
in the
fast,
light
like
pollution,
what Molly was saying.
Even in the light pollution, you can still do broadband. You just need to shoot more exposures.
Yeah. Yep.
Right. But I mean, you're going to get, so can we just talk about this a little bit more? When you say you have to shoot more exposures, what are you trying to do?
You're trying to basically get more signal so that when you are subtracting out the sky glow, you're not subtracting out your entire object, because you'll have your sky glow and your object will be right on top of the sky glow. And so I think it's sky glow here, object here. And if you're in a really dark sky, you'll have object and just a little bit of sky glow, but in a bright sky, he'll have sky glow object. So you need a lot of data to basically pull the object out of the sky glow.
Right. And is it so could you make an image without a narrowband filter, just using time instead of technology.
Yes.
Yes.
That's what I do with my color camera here.
I do that. I do that all the time.
Right.
Yeah.
But it could take, 8 times as much time to get the equivalent signal.
I do sit on a target for 10 plus hours to get a good enough signal.
Right.
Oh, yeah. I usually go 10 hours minimum.
Right. And so the advantage of going to like a really dark sky place is that you're going to get your shots, you're going to get your signal faster. You get your data faster.
Exactly.
Because there's less, you don't have to, like, the more frames you have, the more you're going to be able to pull the signal from the target you're after out from the noise of the light pollution. And if you're in a darker place, that light pollution noise is far lower, and that makes your signal sit a lot higher above it, and you don't need nearly as much data to make a nice image.
Right.
Since I'm in the future, who can tell me what this is?
Oh, you did it! Is that the Orion Nebula?
Yeah.
Nice. Yeah, it's not high enough for me yet.
That's our first shot of the Orion Nebula of the season.
So.
I'm pretty happy with that, considering how close it is to the moon right now.
Yeah, that's terrific. Look at that.
I have a really crummy image of M33. Somebody asked for it. So.
Yeah, we'll go check that out. But hold on, I just want to sort of look at this this shot of Orion first.
Yeah.
That's gorgeous though. Look at that. And again, that's another super tricky object to image because it's so bright. That center is off the charts bright.
Yeah, there's no detail there. Let's that's the raw image, and even in the raw image you can see it's just kind of blown out there in the center.
Right.
Yeah, that's another beginning image, like the Andromeda Galaxy, that everybody tries for and nobody gets right because the dynamic range is so huge. It's really hard.
And it is funny when you see people's pictures of the Orion Nebula, you're learning more about their artistic sort of aesthetic sense than you are about the than the picture itself. Because a lot of times some people will really try to go after getting in the bright areas, but also show in the dimmer areas, and other people want to let the middle blow out and get more of the subtler features around the outside, and sometimes it looks like super garish, and other times
if you look at the full the complex, I mean, if you take just M42, people start making it look like cotton candy.
Yeah.
But if you get the whole complex, there is so much dust lanes in there that's brown all around the edges and dark. It's really cool.
Yeah.
It's amazingly complex.
Yeah. Fantastic. Wonderful. I'm so glad. I didn't think this was going to happen this early on in the season. So for the rest of us, we still have to wait another while.
Another
before
3 hours.
Yeah, another 3 hours. Yeah, you're telling us what our future will be like. All
I
right,
can tell
Stuart.
you how the world ends.
All right, Stuart.
What color for you?
Okay, so this was for Nicole, who's not here, but this is M33. It's a 2-minute exposure in luminance of, and it's a flocculent galaxy. And Nicole just likes saying the word flocculent.
Yeah.
So this is for you, Nicole, and your class.
That's terrific. If they're watching, fantastic. All right, Roy.
I've got the blue Snowball.
Oh, great.
Black
Okay.
and white here.
Wonderful. Okay. Well, we'll look at Roy's
Sure.
NGC 6853. That's the dumbbell, right?
Correct.
Yeah, that's a real nice shot.
Yeah, that's beautiful. Look at that in color. Wow. And so the different colors that we see in this shot, what do they map to?
So the red. Oh, go ahead.
Because it's color, the red, all I know is hydrogen. It's hydrogen alpha.
And the blue is oxygen.
Yeah. Yeah, and the edges, the red that's on kind of the sides there is the bow shock, the shock front of the superheated stellar material that's being blasted out from the center star there, and it's heating up the hydrogen gas that's in the interstellar medium, the gas that's between the stars, and causing it to glow red on those front edges of the ellipsoid there.
And this is an actual color camera, so this is the color that it is turning.
Yeah.
If you could look for
to an approximation of the color levels and stuff like that in the image viewing, but that's approximately the colors it is. Yeah.
Yeah, that's great. So people are asking which part is the blue. I see the green, the blue-green, this color.
Yeah, the
teal.
oxygen glows at 503 nanometers, so it's right in between blue and green. So if anybody argues over, oh, it's blue, oh, it's green, you're both right.
Yeah. This is oxygen. This is hydrogen.
Yeah.
And this is a dying star. So this is a star like our sun, but a lot, billions of years into the future, in the process of sloughing off its outer layers and turning into, or is now a white dwarf in the middle.
Yeah,
technically already dead, I guess.
Yeah, and our own sun will be doing something like that in the future, about 5 billion years from now.
Yeah. That's beautiful.
One of the things I've wondered about those planetaries like that, and I've never had a chance to dig into it, is if the fact that you see the hydrogen on the outside and the oxygen in the middle, if that's actually showing you basically the layers of where fusion happened in the star, since all the hydrogen in the middle was consumed, and then it started fusing helium into other things. So you get a little bit of hydrogen on the outside and then other things in the middle. And if we had more kinds of filters, we might be able to see other elements in concentric rings. I'm not sure if that's the case or not.
You do notice the X. So there's hydrogen throughout, and the hydrogen on the edges is actually not hydrogen from the star so much as it is from the interstellar medium.
Oh, that is run into? Okay.
Yeah. But if you're thinking about the Ring Nebula, for example, or the Helix Nebula, you do have, although I think a lot of the hydrogen on that ring is also from the interstellar medium, because by the time the star is dying, it's because it's run out of hydrogen, and it's been having to burn heavier elements. That's why there's oxygen there, and why there's, if we had a nitrogen filter, there'd be nitrogen and stuff like that. It's because it's had to burn these heavier elements less efficiently than it can burn hydrogen because it's run out.
Right, but the hydrogen it burned was in the core. The stuff that was on the outside never got consumed, was what I was thinking.
There's a lot of convection in stars.
But not
some layers do form. Let's see, I'm trying to remember my astrophysics classes from 6 years ago.
I know on the supergiants they get these onion skin layers.
Yeah, that is true.
Yeah.
Then that's when you get these helium flashes and stuff like that. I think that a lot of the hydrogen in the outer ring is from the bow shock, from the shock front interacting with the interstellar medium. But there may be hydrogen that's kind of escaped out to the outer edges.
Yeah, so when the star is dying, it goes through these pulses, so it sort of expands out and then contracts back down. It's essentially the heat in the center of the core heats up and heats up and heats up, and that causes the star to actually expand outward. And then because it's bigger, it gives it a chance to cool down in the core, and so it shrinks back down and leaves a whole bunch of these outer layers just sitting out there in space, and then it sort of is blowing them away with this stellar wind. And so in the final stages, the death throes of the star, it sort of does this out and in a bunch of times and sloughs off these outer layers. And then depending on what the state of the planets are, and if it has some kind of binary companion, these sort of blend up these outer layers and cause more of the interesting shapes that we see. That's why each planetary nebula is its own special, shape. Molly, what have you got here?
Yes, I've got the blue Snowball Nebula. This is another planetary nebula like the Dumbbell, but it's smaller physically, not by a whole lot. And it looks smaller because it's a lot further away than the Dumbbell Nebula. Although from what I was reading about it, it looks like its distance is not very well known. So therefore its size is not very well known either. So we're looking at this through an oxygen 3 filter. So we're seeing the glowing oxygen gas that was ejected by this dying star. And it's got some really interesting structure, as you can see here. I've sharpened it up a little bit to bring it out a bit more, but kind of this inner ring and then an outer ring. And actually, I just took some 10-minute exposures of this in the last couple of weeks that I'm in the process of processing into an image. It's actually got an outer halo that's about twice the size of the inner core. That's also primarily oxygen. There's some hydrogen in there, but it's a dimmer signal than the oxygen is. There's a lot going on, a lot of interesting dynamics happening in this planetary nebula.
And every shot that I've taken of this, it just looks like a little blue ball.
Yeah, you have to have a fair amount of focal length. My current focal length that we're seeing here is 1280 millimeters, since I have the focal reducer on my 8-inch Schmidt Cassegrain. But I've zoomed in the frame to see it, but definitely get some detail at that focal length.
That's terrific. All right, let's see, Linda.
Got more of Orion's greatest hits.
Yeah,
Excellent.
no, I'll play this song. This is all right.
So I've got an interesting comparison for you. This is 2 minutes of hydrogen alpha data. And let me rotate that so it's the same. This is 2 minutes of luminance data.
Wow.
You can barely see the Horsehead there, whereas 2 minutes of hydrogen, it just pops right out.
Wow.
This is why I like imaging in narrowband so much.
Yeah, I see. For me, it's black and white. I just
Well,
like color.
When I go to process it, I'll make it colored.
Yeah, we just don't have time for that at the star parties. That's all.
Yeah.
So in your mind's eye, just take all of this glowy gray stuff and make it red.
Yeah. Yeah, but it's beautiful. Can you zoom in on the horse?
Of course.
Of course.
Well, that's too much.
There, that's perfect. Look at that. That's incredible. Man.
Oh, the moon's finally come up. I'll get that ready to roll.
Oh, wonderful. Okay, great. Yeah, that's fantastic. I love the shape of it.
Yeah, this is, one of those pictures that as a kid, when you look at it in an astronomy book and you go, wow. And of course, it's one of the first things you want to go see when you get a telescope, and it's actually kind of hard to see visually.
You can't, yeah, I've never seen it like just with my own eyes.
No, it's
The
tough.
Horsehead?
Yeah.
I've seen it once, and it was in a really dark site in a really big telescope with like a special filter to help bring out the nebulosity.
The Horsehead
But with-
Nebula
And
filter.
it was still hard to see. It was
Yeah.
way cool though.
But with the narrowband, it's right there. That's the magic of imaging.
Yes.
The first time I imaged it, I finished it and I go, okay, I'm an astrophotographer now.
Yeah, I mean it's a much more satisfying object to be able to image than like Orion or M31, just because it's just, I mean, it has a very bright star right beside it,
Yeah.
but that's not in this image. So
It's just
is it Alnitak?
Alnitak is
Yeah.
right there.
Yeah.
And so it's illuminating the Flame Nebula just below that.
Yeah, I'll go get that one next.
Oh, sure, that'd be great. All right.
Got Pacman.
Oh, good. Okay. This is when I always make when I ask the question, right? What do they call this nebula before Pacman?
I think it's NGC 281.
Yeah, it's 281. I've got the color version of it.
Oh, great. Okay.
Yeah, you say great now, but wait till you see it.
So So Edward Emerson Bernard discovered the nebula in August 1883. And he right away thought it looked like Pacman.
In a moment of prescience.
Yeah, I'll call this the Pacman Nebula. And so the video game was named after this nebula. No.
You know,
No.
he named it that because he had just gotten back from his time travel seminar.
Right. So what's cool about this, again, like, see the sort of down near the bottom here, you can see, again, more of these, like, pillars of creation
Right in this area
structures. Yeah. And these guys are Bok globules, these little darker spots inside. And so inside those, they're hiding.
Wait, they're not globulous?
Globules. Bok globules. So there's probably stars forming inside those little dark regions. And that's awesome. All right, the moon. Oh, fine, moon. You can last one more month.
Yeah, I'm imaging a narrow band while the moon is bright. Well, I do have my color camera up imaging as well, but I'm having to choose my targets carefully to stay away from the moon. But as annoying as the moon is for doing deep sky astrophotography, it's also really gorgeous to look at, and especially if you're at the eyepiece yourself or at the camera. So we're not quite full yet. That's like a day and a half off. As you can see, if I zoom in here to the Terminator, you can see that it's not full, not quite fully full. We've still got some shadow on the craters on the edges here. And this is the you actually want to go, if you're going to go visually observe the moon, you really want to go look at it when it's not full, partly so that it doesn't blind you. and partly because seeing the craters partially shadowed is the really cool part. It makes it look 3D, which, I mean, it is, but like it's hard to see that 3D-ness from all the way down here on Earth.
Yeah.
You can kind of get a sense of depth of the craters, to see some really gorgeous contrast. And we're at since the moon is approaching full, we can get a really nice view of Tycho crater here. And you can see its ray structure. So this was a major impact on the moon, enough where it ejected material miles and miles. This is probably representing something like hundreds of miles away from the crater, maybe even 1,000. I have to go look and see how long these are, but hundreds of miles at least away from the crater, kind of leaving this big hole and all this ejected material.
And the way that astronomers figure out how old features are on the surface of places like the moon, Mars, Mercury, things like that, is they count craters. And you can see how the craters are layered on top of each other. If you zoomed into that Tycho crater, there would be other craters that had smashed into the ejecta that the Tycho crater had sort of sprayed out around it as well. And so there's real value in being able to count craters. And actually, we did that with a project with CosmoQuest. People were counting craters on the moon and Mars to try to figure out how old various landscapes were on the moon.
Also, one other thing I want to point out is the Apollo 11 landing site, which, you can't see it from here on Earth. In fact, even the Lunar Reconnaissance Orbiter, a satellite that goes around the moon and images it, still has a hard time picking it out. But it's right about here is where that landing site was.
Hold on 1 second. I think we switched over to Roy's shot here.
Oh, sorry.
No, it's okay.
I'll just take all the screen time.
Yeah. Hold on. I'm trying to figure out a way that I can. Does that work? Oh, remove the pin. How do I see the pinned content? This is going to bust, isn't it? All right, I'm going to turn off your screen share for 1 second, Roy. This is not personal. All right, there we go. All right, go ahead.
So right about right about here. And this is the Sea of Tranquility. And I'll zoom out here in a bit so you can kind of see where this is at. But right about here is the Apollo 11 landing site, kind of in this little jet, kind of near the shores of the Sea of Tranquility, if you will. And if I zoom out here, maybe not that far, you can see that that's right about here. So there's this big distinctive sea here, which is the Sea of Serenity, and then the Sea of Tranquility is just below it here.
Do you know where the Chang'e 5 is going to be landing?
Is that one? I think that one's going to one of the poles, isn't it? Like the South Pole.
Let's see.
I haven't.
They're going to the going to the Oceanus Procellarum.
Oh yeah, that's
the Ocean of Storms near the western edge on the near side of the moon.
Yeah, so the Oceanus Procellarum is this huge area here.
Okay.
Let's see, I'm looking at my moon map right now. Actually, sorry, it's a little bit rotated. It's this area.
Okay. Yeah, so and they're going there because it's a much younger landscape than some of the older regions that the Apollo astronauts brought back. And so it's kind of amazing. Within 3 weeks, they're going to bring back a sample from the surface of the moon for the first time in 40 years. The last time to do this was a Soviet sample return mission that was there in 1976.
Wow.
You can see how the surface looks younger because it's got a lot fewer craters in it. And so that means the lava flowed over at some point in its geological history, and not as many meteors have impacted since then. So that's what tells you that this region is younger than other regions of the moon.
Yeah, so cool. All right, Roy, share again.
Okay. This was the, this is going to look nice. That's the Pacman in color.
And did you get Starlink there? No, it's an airplane.
Yeah, it's an airplane.
Yeah.
Yeah, so that's the downside of color is you don't get the same detail.
How long's your exposure?
That's 3 minutes.
Wow.
And the
well, it says 300 seconds. That's 5 minutes.
Moon is killing it.
Yeah.
Or no, that's 5 minutes.
Yeah.
Excuse me, 5 minutes.
Still, I'll take it.
I have the double cluster. Double cluster. We haven't seen that this year yet.
Oh yeah. How? What?
So this is a spectacular thing to look at with an eyepiece.
Yeah.
And it's one of the few things that I actually enjoy looking with an eyepiece more than I enjoy imaging it, because imaging is kind of a pain. But eyepiece is just glorious to see, especially in a dark sky. Get a nice telescope with a wide field eyepiece, and you just see these two jewels, and it's just glorious.
Yeah. It is beautiful to see in the telescope.
Yeah. And these are two NGCs, 869 and 884. And according to my database, it was discovered in 130 BCE.
Really? Someone had really good eyesight. You can definitely see it. Like in dark sky, you can definitely see the double cluster in the sky.
Bright.
Yeah.
It's very bright.
Yeah.
With your eyes.
They didn't have much light pollution back then.
Mm-hmm.
Yeah. It's funny. I don't know if you guys have done this, where you just lay out with a pair of binoculars and you just like look around the sky and look for any fuzzy bit, and then you follow up with a pair of binoculars and you see something.
My eyesight, most of the sky is fuzzy bit.
Yeah, I mean, maybe it was a thing I was able to do when I was a lot younger.
Yeah, I end up stumbling across it every time I'm looking for the Andromeda Galaxy with a pair of binoculars.
Yeah, it's not too far away.
Yeah, and it's so hard to miss. You're kind of just waving your head around, and you're like, oh, what's that? Oh, that's really pretty.
Linda, so you did get the Flame.
Yeah, Flame Nebula, which and in relationship to the Horsehead, it's just off the frame down there, so they're very close.
Right, you could
Alnitak's
stitch
here.
those two pictures together into one mosaic.
If I had a little more control over this telescope, I could get them both in the frame, but I don't have. I need to hook up to a planetarium program so I can point more precisely.
Jeff Weiss is asking, what software programs are you using to display the objects?
In my case, I'm using Voyager, which is the software that this telescope uses. And this is just the viewer that Voyager provides.
I'm using PixInsight. It's the processing program that it just makes it easy to import and auto-stack.
For me, I'm using AstroPixel processor, which then I just export it to a JPEG and then just show the JPEG in just a normal viewer.
Mm-hmm.
I'm using a SharpCat to display. It's got a lot of really easy to use image adjustment functions just for live viewing, and it's got a live stack feature as well that I use for the deep sky targets.
Nice.
I'm using the SkyX to control the paramount.
So the Flame Nebula, that's now that bright star is that the one that's illuminating it, or is it got stars inside of it as well?
I'm not sure, but I suspect that Alnitak, this bright star here, which is one of the stars in Orion's belt, is
yes,
illuminating part of it.
Yeah,
so.
It's shining energetic ultraviolet light into the flame. This knocks electrons away from the great clouds of hydrogen gas that reside there. And so much of the glow results when the electrons and the ionized hydrogen recombine.
It's kind of interesting, though, because compared to the Horsehead, where you get this, red hydrogen glow that we're all familiar with, but the Flame Nebula looks more of a peach color in color photographs that are broadband filters. So it's one of the more interesting objects because it doesn't look like everything else.
And so then at the core of it, there's a cluster of newly formed stars. So at the very center of it.
Yeah. We've got this big, giant dust cloud obscuring part of it.
Yeah, so you can see through it in infrared and actually see the stars. But that darker area in the middle of it is dust that's obscuring our view in the visual spectrum. Douglas Clausen is asking if you can zoom in to the flame. It feels like a tear in the space-time continuum.
Looks like some special effect that you'd see on Star Trek.
Yeah, it's funny. I'm looking at some pictures, it's like some amateur shots, and it's kind of amazing. I'm gonna try to.
I think it looks like a tree on fire.
Yeah.
Yeah, it's one of the most aptly named objects.
Yes, agreed.
Yeah, I'm gonna try and show a shot, like another shot from somebody. You could sort of see what it looks like in color. It's just crazy. All right, Stuart, you got something?
Yeah, this is Pickering's Triangle. It's part of the Veil complex, and the people who are wide field can get all of this in one. I can just do little bits of it. And so
yeah.
There's the Eastern Veil, the Western Veil, and in between the Eastern Veil and the Western Veil is this, which I actually like better than both of them. But I have them both. If we have time, I'll show you. But I like this just because of the sort of looks like a little spaghetti of hydrogen alpha that sort of winds its way across the viewer.
And of course, this is the part, as you mentioned, part of the supernova complex.
Right.
It's like one of the largest objects in the night sky, and it is the expanding huge wreckage from a supernova that went off I think something like 10,000 years ago. And it's big but faint, and yet still has all of this really beautiful structure. And it's just kind of amazing to think that this is all just the wreckage from a star that detonated.
Yeah,
So,
live hard, die young, and leave a good-looking corpse, right?
Yeah, I don't know I guess so. Yeah.
It's pretty incredible to look at in the eyepiece if you're somewhere dark and have a good like contrast enhancement filter.
Yeah.
It's really cool to just kind of take the Dobsonian and kind of just move around, check out all the different parts.
So how well are you able to see this one visually?
Not well at all.
Yeah, Pickering's is the most difficult part of the whole thing to pick out.
But you can see like the veil and the witch's broom parts of it.
Yeah, the eastern and western parts you can see, especially with a filter. It's not too difficult.
Yeah.
But Pickering's triangle is much fainter.
Yeah.
I want to see part of the veil in color.
Sure.
Yeah.
Got it here. I just got to find what I did with it.
Are you setting us up again?
No, this actually looks good.
Which part are you showing, Roy? I'm not on that screen.
Yeah, I got to find it first.
Okay. Well, I've got the eastern veil up.
That's great.
There it is.
Ignore Pickering's triangle. So I don't know what you're going to show, but I don't.
6960.
69 what?
6960.
6960.
Oh, okay. So you're showing western veil. Let me pull that.
Yeah, I always get them mixed up.
So I'll just show you. I'll just show you the whole thing here quickly as Roy's is showing up. So this is a view from NASA that was shot of the whole complex. The Cygnus. It's called the Cygnus Loop, and so the two brighter parts, the veil is here, and the witch's broom is here, and this is the Pickering complex that Stuart was showing as well. And there's all kinds of little pieces. And so this is the whole thing. Kind of looks like a skull, actually. I thought it was more of a circle, but it's kind of a little blown out on the bottom here. But but that's the whole region. And so again, an astronomer with a really wide field of view can just get one little piece of this. I don't know of anybody who has a telescope view wide enough to get the whole thing.
If you have like a 200 millimeter lens or 300 millimeter lens, you could probably get the whole thing.
Yeah. If you have a camera lens,
And this shot is in ultraviolet, so you're not getting all of you're just getting the one color, ultraviolet. So it's a NASA shot. But so there's the veil. That's the witch's broom. Sorry, there.
Right, and I have the other side of it.
Oh, great. Okay, yeah.
So you can flip back and forth and see.
That's terrific.
So
I do love the color. So once again, we've got the red of the hydrogen, we've got the greeny blue of the oxygen there, and it's like when you think about the Death Star exploding, you've just got this ripple of material that's slowly expanding outward from the detonation site.
Yeah, and this is just one single 5-minute image. If I had enough to stack this, it'd really pop out.
Yeah, and there was no stupid moon.
Yeah, there's that too.
Yeah. Fantastic. And then Stuart's got the
This is the eastern veil.
Whoa, what have I done?
Oh.
Wow, I think I did something.
The heck? That's very strange.
I'm really digging this. Okay, hold on. Let's go back to me. I don't know what I did.
Circles within circles.
Whoa, look at that.
No.
Okay, I'm going to turn off
I think the app is kind of panicking.
I'm going to turn off my virtual camera and turn it back on again. Let's see if this works. Nope. I think we're
on Earth.
Yeah, I think we're reaching the end of the... All right, well, I'm going to stop my virtual camera then. And fortunately, I've got more virtual cameras. All right, let's see if this fixes it. Nope.
That's weird.
My God. That's funny.
I have one more image for you, Fraser.
I might have busted OBS here.
dear.
I'm trying to think what I can do. Because every time I switch over, all right. Let me turn off the full screen. Let's see if that does it. And I'll have no. All right, let's try that. And we'll put you all back. No. This could go horribly wrong. All right, so it was whose shot was I looking at? I was looking at. We'll go to Molly.
You're gonna go to Roy.
Yeah,
Roy.
well, going to Roy's was what broke it. So.
Oh, all right.
Go to me.
So we're gonna go to Molly
Yeah,
and let's see what happens. It's stable.
Oh.
Okay.
Weird.
Okay. And then let me try turning on my virtual camera again and switching to the virtual camera. And I think we're okay. Tell us what this is, Molly.
So this is M76, the Little Dumbbell Nebula.
I like that one.
Yeah, it's you can kind of see its shape is reminiscent of the Dumbbell Nebula, although if you look closely and take some longer exposures, it's kind of got more of a apple core with what I think are butterfly wings. My mouse isn't, there we go. Like an apple core with some butterfly wings. And this is in oxygen 3 again, but it's got a lot of hydrogen as well. And I think what I'll do is I'll stack up a few oxygen images here to look at, and then I'm going to switch filters to the hydrogen, and we can see what the hydrogen looks like and how it's a sort of a different shape and makes up a different part of this nebula. It kind of looks like either a fat butterfly or an apple core with wings. Or a weird dumbbell, I guess.
Yeah, and so it's we saw the regular dumbbell, the big dumbbell, the dumbbell, and then this is the little dumbbell.
Yeah, this one's a lot smaller.
Yeah.
This was in my 8-inch. It's not as small as the blue Snowball, but it's definitely would be a challenge to capture well in a refractor, for instance. It is smaller than the regular Dumbbell Nebula, and let's see, looking at some info. How far away is this guy? It's not really well known how far away it is. I guess the distance ranges from 1,700 to 15,000 light years of distance. So since we don't really know how far away it is, we also don't really know how large it is physically.
That's cool.
Yeah, I'll switch over to hydrogen here.
Oh, sure.
While you go on to the next person.
Oh, so have you got it ready, or are you just gonna?
No,
gather?
I've got to
okay.
acquire some images.
Yeah,
I've got one for you.
Yeah, Crab Nebula.
Ooh.
Yeah.
And you got Starlink.
Ooh.
And yeah, we got a satellite buzzing us.
I feel bad saying that it's Starlink specifically, especially because I'm on the wait list to try to get Starlink. I can't wait.
We can process them out.
Yeah, I can't wait. I can't wait to use Starlink to capture images to then remove Starlink trails from my images.
Yeah, right.
Yeah, no problem. I'm willing to sort of handle that balance. That's great. That's terrific. I love the.
This is a much younger supernova remnant.
Yeah.
Only about 1,000 years old.
We can see it so brightly because it's still getting new energy, not just from the remaining supernova, but there is a rapidly spinning pulsar in the center of it that is emitting a lot of energy. A pulsar is a neutron star that is spinning like a top, which and it's emitting a lot of energy, and it's got a really strong magnetic field that does a lot of interesting dynamics to the nebula as well.
Terrific. Well, we've reached the end of our hour. Molly, you have a final hydrogen alpha shot. Does anyone have any last
here's
points they
hydrogen
want to
alpha
share?
shot here.
All right. Well, Molly, we'll do Molly's here, and then we'll. So that's that's the alpha. You can see more structure.
Yeah, it does look fairly similar to the oxygen one. Although if you were to compare the two side by side, I think you would see that the core region has different concentrations hydrogen, like this brighter spot down here, whereas it was more spread out for the oxygen.
Yeah.
And the wings are a little dimmer in hydrogen than they were in oxygen. But when you put the two together into a color image, then you can get a nice.
Are you gonna do that now?
I can show it.
Wow.
Well, not. This is when I processed.
Oh, okay.
Previously. There we go.
Nice. When the moon
Yeah,
wasn't.
so you can kind of see how there's the concentration of hydrogen kind of on the top and the bottom there.
I mean,
like
most astronomers don't even set up their telescope on a night like tonight.
No.
No, for about a week, they don't even go near their telescopes when the moon is up. Fantastic. Wonderful work, Molly.
Thank you.
So, Fraser,
Yeah.
I have one more that I wanted to show you.
Okay, and so just to warn everybody, if this like breaks my streaming software, then this is how we will be remembered.
Okay. This one isn't specifically live. It was from last night. It's a single image.
Oh, the rosette. Nice.
Fraser loves the
Ooh,
rosette.
Fraser loves the rosette.
Here's the interesting thing with this. This is with my color camera
This is a
using
color
a hydrogen
picture?
alpha filter.
Oh, really? I've been curious about how that turns out.
So this
Like this.
camera, if I bin it in 2x2, there's a special mode in there where in software it will take the Bayer matrix and do some math or whatever and make it pretty close to a monochrome image.
Huh.
So I can shoot through narrowband filters with my color camera.
And so and then shoot with a different filter, and then shoot with a different filter, and then build it back up. And so you don't need to run a monochrome camera to shoot narrowband. That's really interesting.
So you're just sacrificing resolution to do that.
And a little bit of signal. It's not going to be as bright, but it's
pixel
cool.
camera. So
Yeah. So you got the kind of the best of both worlds.
Interesting.
That's beautiful.
yeah,
Wonderful.
I mean, binning it 2x2, 64 megapixel camera, I'm still getting good resolution.
Yeah.
Yeah. That's really cool. What a great technique. Okay, great. Well, I think Stuart's already shut down there. So I'll put everybody back on the screen here. Let's see if I can make this go. Gallery. Man, they just made this so complicated. All right, I can turn off my virtual camera and then use my regular camera. There I am. Okay. All right. Well, thank you, everybody, for joining us tonight for this week's Virtual Star Party. Great work from all the astronomers tonight. You were all just a well-oiled machine. This was terrific. We show more images now in 1 hour than I think we ever could have hoped to in the olden days. So that was absolutely fantastic. Thank you to everyone watching. Thanks to the moderators, and a special thanks to Nancy Graziano, who has been working so hard behind the scenes to try to organize all of this. The fact that it runs so smoothly is really entirely her fault, her victory. So. So hopefully we'll go next week. How's everybody's darkness? Think we can go to 6?
Yeah, I could.
Yeah, Stuart.
Probably.
Yeah.
I could probably go to 6. It takes me a little while to kind of get everything moving, but I'll do the best I can.
Okay. Yeah, I don't want to put you out, but I just think
it's fine. It's just
help.
I have to roll everything out, set everything up, do all my focusing. Molly, all she has to do is flip a switch. So
Yeah, pretty much. Yeah, it's pretty great.
so it takes me an hour setup. That's the only thing. So.
And then just a reminder to everybody, if you can, just throw some pictures into the folder for this week so people can download and use them for their screensavers and so on. Sure. If people want to find out more, Stuart, where do they go?
I don't have any fancy websites. I'm just on Twitter at Stu Foreman, S24MAN, S24Man.
Roy?
I have a website, but it's really, I don't be putting pictures up there. I'm still trying to figure out how to get them off of Google Plus. So
Oh no.
They're gone, Roy. Yeah,
Just give up hope.
I can solve that problem for you.
Figure out where to put them.
Yeah. All right. Molly.
I am at astronomolly.com and on Facebook, Astronomolly Images, and that's where I do most of my posting. You can also follow me on Instagram at astronomolly_images.
Linda.
You can find my stuff at lindasastronomyadventures.space or on YouTube at Linda's Astronomy Adventures.
Fantastic. All right. Well, thank you, everybody. And hopefully we'll see some combination of you next week.
Awesome.
Thanks a lot.
Good night, everyone.
Good night.